Question 13. A hollow cone of base radius 30 meter and height is 8 meter. So as a diagram show here, we can see our shape here is a cone. So radius is 30 and then height is 8. So it's held with its vertex downwards. The oil is going to pour inside at the rate of 45 meter cube per minute. So we get the information here where we're going to pour our oil inside this conical tank. So as we pour our oil inside our conical tank here, so this is our radius of our oil, and then this is will be our depth of our oil or height of it. So from here we can see the rate of change is 45 meter cube per minute. So meter cube is a quantity of volume. So dV dt is equal to 45. So this volume, when you pour it inside, it is an increasing situation. So we will have positive 45 here. And then for the next sentence here, find the rate of increase of the depth of the oil. So we're going to find out our dH dt, which means find out our rate of change of this height when the depth. So when the depth means when our h is equal to 3. Correct the answer to 3 decimal place. So from here we can see what we want to find is dH dt. So dH dt, we can find it by using chain rule, where we can link our dH to the quantity of V, and then dV link back to T. Because dV dt is already obtained, so that's why we will link our H to V and then V to T. So as we can see here, dV dt already given. So now we're going to find out dH dV. Means we're going to find out formula of the volume of the cone. So as we can see, our volume of the oil here is in the shape of the cone, because liquid shape will be follow the container shape. So the volume of the oil will be equals to 1 over 3 pi r square h, which is the formula of the volume of the cone. And we can see here we want to differentiate V with respect to H. So our formula V here must be in term of H, must be in term of one variable. We cannot have two variables together inside the formula. So in order to change our formula in terms of H, we have to find out the relationship between R and H here. So we can use the concept of similar triangle. As we can see in the diagram here, we have two triangles. From the cone, from the tank, we have, from this tank, we have this triangle, which is a similar triangle to the triangle inside for this oil. So for this tank, the radius is 30, the height is 8. Meanwhile, for the oil here, the triangle shape that form out, they are similar triangle because they're having the same angle. So the triangle formed out by this oil, the radius is unknown variable r, and the depth is the variable h. So we can use our similar triangle here to form a ratio. So the ratio here will be r ratio of radius. So r will be ratio to 30 equals to ratio of the height. H will be equals to 8. So we're going to express r in terms of h. So it will be 30 h per 8. So r can be simplified here. It will be equal to 15 over 4 per h. So after we get this ratio, we can substitute inside our formula of the cone. So our formula of the cone here can be 1 over 3 pi, where r is 15 over 4 square times h. So now our formula is in terms of one variable. So as we simplify the square here and multiply with 1 over 3, our formula will be equals to 75 over 16 pi. So h squared times h, we will get h cubed. So from here we can differentiate v with respect to h. So power will move to the front, and then power minus 1. So what we need to find here is dh dv, so we will inverse our dv dh to become dh dv. So denominator will go up and numerator, everything will go down. So finally we managed to get our dh dv. So we are going to answer our question by finding our dh dt is using our chain rule. So plug in our information here equals to 16 over 225 pi h squared times dv dt, which is 45. So dv dt is given, and we have a variable h here, and h is given, which is equals to 3. We substitute 3 inside, and we're going to press calculator to express our final answer in 3 decimal place. So our answer will be equals to, so height is in the unit of meter. So we can see unit of meter, time is in the unit of minute. So meter per minute. The rate of change of the height of the oil will be equals to 0.113 meter per minute.